Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how space travel impacts eye health. Space enthusiasts are not crazy about popular tourist destinations like London, Paris, and Rome, but they wish to travel outside of Earth. Space tourism, which is not limited to astronauts only, has become a new norm in the recent past, with several companies having come up with this concept, which is attracting people worldwide. But no doubt it is costly. Some companies in the aviation industry are aiming at giving tourists the ability to become astronauts and experience space travel for recreational or leisure purposes. But at what cost? Some studies have highlighted how space travel and altered gravity might impact the human body. The latest study, titled "Ocular Perfusion Pressure is not reduced in response to lower body negative pressure," focused on some of the impacts, specifically effects on the eye. The study, published in the journal NPJ Microgravity, was led by Dr. Ana Diaz-Artiles. Experts have already established the fact that body fluids can change as a result of the gravitational changes astronauts experience while in space. The latest study suggests that the cardiovascular system, especially the vessels in and around the eyes, may be affected by this. When we experience microgravity conditions, we see changes in the cardiovascular system because gravity is not pulling down all these fluids as it typically does on Earth when we are in an upright position, said Diaz-Artiles, as quoted by phys.org. Artiles is an assistant professor in the Department of Aerospace Engineering and a Williams Brothers Construction Company faculty fellow. When we are upright, a large part of our fluids are stored in our legs, but in microgravity, we get a redistribution of fluids into the upper body. Artiles added, "The study mentioned that lower body negative pressure has been proposed as a countermeasure to mitigate the fluid shift occurring during spaceflight, which may be associated with the development of spaceflight-associated neuro-ocular syndrome." Diaz-Artiles and her team hope to explain the underlying mechanism behind this issue, as researchers are unsure of the exact cause of SANS. The team is also probing potential countermeasures to help counteract the headward fluid shifts of SANS. This research is just one experiment of a three-part study to better understand the effects of fluid shift in the body and its relationship to SANS. Previous experiments in this study included the use of a tilt table for researchers to understand the cardiovascular effects of fluid shifts at different altered gravity levels, recreated by using different tilt angles, said Artiles. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.